I'm Anil Kumar. Welcome to my series on input-output machine. This is a very important topic for our middle school students. Let us see how does that work. So we'll take different kinds of input-output machines. Let us say we'll sketch like this a machine in which we'll write down the pattern rule. So if I write here times 5, that means whatever is the input, that will be multiplied by 5 and then we will get an output, right? So that is what it means. So let me draw it something like this. We'll feed in some input to this, and input is in the form of a number, right? And what we get out will be multiple of 5. For example, in this particular case, if I write numbers like input numbers like 1, 2, 3, we could write any numbers, right? We could write 5, 10. In that case, what is going to be the output? The output is going to be multiple of 5, right? That is what this machine will do. So when an input goes into this machine, it will multiply that number by 5 and give us the output. So 1 will get multiplied by 5, we'll get 5. 2 times 5 is 10, 3 times 5 is 15, 5 times 5 is 25, 10 times 5 is 50. So those are going to be the output from this particular machine, right? Now let's work on this for some time. So now we could have a machine which could divide the numbers, right? So we could have a machine which could divide. So let's say we'll divide the number by 3, right? And in this case, let's feed in some inputs and see what outputs do we get. You can actually pause the video now, make a table to show different kinds of inputs and different kinds of outputs. So what inputs are good when you are dividing by 3? Think about it. Well, we should take multiples of 3, right? So the numbers which are good to take are like 3, right? 12, we could take 21, we could take 30, right? We could take 60, for example. So when you divide these numbers by 3, we get 3 times 1 is 3, 3 times 4 is 12, 3 times 7 is 21, 3 times 10, and 3 times 20 is 60. So they become output of this machine. So I hope you have got the concept, right? Now input-output machines could also be combination of two operations. For example, first we could do multiplication and then we could add or subtract, right? So let's now take this multiple by 2 and then we'll add 1. So let this be our input-output machine operation this time, correct? Then what happens to each input? Let us try to see it, right? Well, as I said, you could always make your own table, feed in some numbers, and then check out what is going to be the output. So times 2, add 1. So let's write down few numbers this time. You could write numbers like 1, 2, 3, 4, and 5, right? So if I times 2, 1 times 2 is 2, double the number, add 1. So it becomes 2 plus 1 as 3. 2 times 2 is 4, 4 plus 1 is 5, 3 times 2 is 6 plus 1 is 7, 4 times 2 is 8, 8 plus 1 is 9, and we get 11 here. Like this, you can feed more numbers. Do you get an idea, right? You will notice that if I reverse these operations, we'll actually get different result. For example, if I add 1 first and then multiply, what will I get? Let's say we add 1 and then we times it with 2. Now for this operation, I would like you to make your own table and see what results do we really get, right? So this time to every input, we'll first add 1 and then we'll multiply by 2. Okay, so let's say input and output, correct? So again, let's take numbers 1, 2, 3, 4, and 5, and we can compare our result. Adding 1, then multiplying by 2. 1 plus 1 is 2, 2 times 2 is 4, right? 2 plus 1 is 3, 3 times 2 is 6. So when 3 is fed in, 3 plus 1, 4, 4 times 2, 8. That is how we are writing our numbers, right? 4 plus 1, 5, and then times 2, 6 times 2. Do you see? Well, this time what we got was all even numbers, and earlier we got all odd numbers, right? So that output was odd numbers and this output was even numbers. So different. Well, both are skip counting, right? Both are skip counting, but they are different numbers, correct? So now for you, let me have an input-output machine in which we'll multiply by some number and then take away, right? So this time, let's times it by 4 and then take away 1. Now I'd like you to think about few numbers, times it with 4 and take away 1. Perfect. I will also take some of my numbers. You could take any number you want, correct? Okay. Now once you do that, we'll discuss more about input-output with the help of examples. Okay, this time let me take numbers like 2, 4, 6, 8 and 10. So if I multiply by 4, 4 times 2 is 8, take away 1 means less 1, 7. 4 times 4 is 16, 1 less than 16 is 15. So multiple of 4, 1 less. 6 times 4 is 24 and 1 less is 23. 8 times 4 is 32, 1 less is 31. 40, 1 less is 39. So you could get a series something like this. Perfect. So that is what our input-output machine is. Now based on this, we could actually have many questions, right? Now to share with you, questions will take some set of questions now and work on those. Perfect. So let me share with you a set of questions with you. So here are lots of questions for you. So we have 5 questions on this page. So it is question number 1 is input-output machine follows the rule add 1 then times 3. Write the first 5 input and output terms for this machine. Now when we say first 5, in that case input should be 1, 2, 3, 4 and 5. Correct? Question number 2. Find 10th and 100th term of the following number patterns 1, 4, 7, 10, 13 and so on. Write the 10th and 100th term. 2, 7, 12, 17, 22 and so on. 200, 198, 196, 194, 192 is decreasing by 2 each time. But you need to write the 10th and the 100th term. Question number 3 is, which of the following number patterns will have 62? Explain. So in these patterns, you have to figure out, do you get 62 in the pattern or not, right? And you have to provide an explanation. Is that clear to you? Question number 4 for you is, find the next 3 terms when we are given the pattern 2, 6, 12, 20, 30. And question number 5 is, if 50 be a part of this pattern, it should be is. Explain if 50 is the part of this pattern, right? So we are given a pattern here which is 1, 1, 2, 3, 5, 8. You need to check if 50 comes in this pattern or not, correct? So these are the questions for you. You can always pause the video, copy these questions, answer, and then look into my suggestions. And now let's check the solutions, right, for these 5 questions. Question number 1. Input-output machine follow the rule add 1 then times 3. Write first 5 input-output terms for this machine, right? So what we will do here is we'll make a column here. So let's say this is our input, right? So input could be first 5 terms 1, 2, 3, 4 and 5. The machine is adding 1 then times 3. So output is basically you have to input, add 1 and then times 3, right? So we do this operation first. I'm putting it in brackets. So for 1, if I add 1, what do I get? 1 plus 1 is 2 and times 3 is 6. 2 times 3, right? So we have to increase this number. So 2 plus 1 is 3 and 3 times 3 is 9. 3 plus 1 is 4. 4 times 3 is 12. 5 times 3 is 15, and 6 times 3 is 18. So that is the output which we get, and these are our first 5 numbers. Clear? Question number 2. Find 10th and the 100th term for the following number patterns. So we have a number pattern 1, 4, 7, 10, 13. We should write explicit pattern rule first, right? How do we get the pattern rule? Now what do we notice here is that each number increases by what amount? 1 to 4, it is by 3, 4 to 7, again 3. So we are adding 3 each time. So our rule will involve 3. What is 3 times 1? 3 times 1 is 3. How do I get 1? Minus 2. So output should be equal to input times 3, and then because it is just 1, we have to take away 2, right? So that is the input-output rule. So using this rule, we will get our 10th and 100th term, right? So if the input is 10, so we have 10 times 3 minus 2, which is 30 minus 2, we get 28. And for the 100th term, we get 100 times 3 minus 2, and that gives us 300 minus 2 as 298. So these are our 10th and 100th term. You get an idea, right? So that is how you have to do for each one of them. The next one here is 2, 7, 12, 17. So we are going up by what number? This time it is by 5, correct? We are adding 5, and therefore the rule will involve 5. 5 times 1 is 5. How do I get 2? Take away 3, right? So the rule is times 5 and take away 3. So that becomes our input-output rule. This time, let me make it like a machine, which we have been talking about. So in this case, if I do 10, so it is 10 times 5, which is 50. And when I take away 3, I get 47. So that becomes my 10th term, right? For the 100th term, it will be 100 times 5, which is 500, and then less 3, which means 497. That is going to be my 100th term. Is that clear? So using this rule, we can very fast, easily find the answer. The last one here is 200, 198, 196, and so on. Well, this time, what are we doing? We are taking away 2 each time. So we are not adding, we are taking away. So it involves multiplying by minus 2. Right? Sometimes what we do here is, you took away to come from here, what was this number before 200? Well, this number should have been 202. That is called the 0th term, right? Nothing taken away from here. But you could begin from here and then take away 2. So sometimes we can actually look for a number which was before this, and then it becomes much simpler to give our rule. Now in that case, the rule will be, you start with 202 and take 2 each time. So now we have to start with 202 and then minus 2 times 1 gives a 200, right? So the rule here will be 202, right? That is where you start with, and take away 2 times the number of terms, right? This was the first term. So from 202, take away 1, we get 200. 2 times 2 is 4. So from 202, 2 times 2 will be 4. You get 198. You get an idea. So think over it and then figure this rule out, correct? So that is the answer. How do you get the 10th term here? So we do 202, take away 2 times 10, right? Which is 202 take away 20, right? So it is 202 take away 20, and that gives you the number. So 2, and then when you take 2 from 20, you get 18. So 182 is your 10th term. As far as the 100th term is concerned, so from 202, you will take away 2 times 100. So that means you are taking away 200 from 202, so that will be 2. So 2 is going to be your 100th term, right? So the 10th term here is 182 And the 100th term here is the number 2. Perfect. So this is a slightly difficult question, but I hope you'll get the concept. So go through it once again. Now let's look into question number 3. Which of the following number patterns will have 62? Explain. Okay. So let's see. 2, 4, 6, 8, 10. So these are all the even numbers. So they are all even numbers, correct? So definitely we'll get 62 here, right? So that is okay because 62 is also even. Next number is 3, 6, 9, 12, 15. These are multiples of 3. So 62 is not a multiple. So 62 will not be there, right? So 62 will be there in this, but not in this, correct? Now next pattern is 2, 5, 8, 11, 14. Now how do you get this pattern? So what we are doing here is 2 and 5, we are adding 3, correct? So we are adding 3. So what could be the rule? Think about a rule now. Rule is times 3. This is the first term, right? 3 times 1 is 3. And how do you get 2? Take away 1. So times 3 minus 1. So 1 less than multiple of 3. Think like this. 1 less than multiple of 3. So 62. 62 is 1 less than multiple of 3, right? So this is correct, right? Because 63 minus 1 is 62. Do you get the idea, right? And 63 is a multiple of 3, right? 21 times 3. So 21st term. Because 21 times 3 is 63 and then minus 1 will give us 62. So that is correct. It will be there in this pattern and be 21st term. Next one is 6, 10, 14, 18, 22. Now here, what is happening? We are adding 4, right? So we are adding 4. So what is going to be the rule this time? Times 4 and then what? Add 2, because you have to get 6 from first term, right? So it will be times 4 plus 2, correct? To get 6 times 4 plus 2. Now, 62. 62. So what is the multiple of 4 very close to 62? So if I do 60, 60 is a multiple of 4, right? So we know 60 plus 2 is 62 and 60 is divisible by 4, right? So 4 times 1 is 4 and then 20 is 15. So 4 times 15 is 20. So therefore 15th term. So you can check. So if you increase this pattern, go up to the 15th term, you will get 62. Perfect. And therefore, this will also be a part of this pattern. Perfect. So this is a very important question which is seen in EQAO and many tests for grade 6 students. Question number 4. Find the next 3 terms of this pattern. 2, 6, 12, 20, 30 and so on. And question number 5. Explain if 50 will be part of this pattern. 1, 1, 2, 3, 5, 8. Now these two are very difficult questions. So I'd like you to spend some more time and get your solution. Now here is the answer. Now this is the first term, second term, third term, fourth term, fifth term and so on. How do we get 2, 6, 12? These are very special numbers. So 2 is 1 times 2 is 2. And 6 is 2 times 3. Do you see? 2 times 3 is 6. 12 is 4 times 3. 20 is, I should write 3 times 4, right? I should write 3 times 4. And 20 is 4 times 5. And this is 5 times 6. Do you see that? So fifth term is 5 times 6. You have to write the next 3 terms. So next term should be 6 times 7. So 6 times 7 is 42. And then we have 7 times 8, which is 56. And then we have 8 times 9, which is 72. So like this, you can continue. So I hope you have understood the pattern rule. It is product of term number and the next number, right? So the pattern rule here is n times n plus 1, right? So you multiply consecutive numbers to get this pattern, okay? Question number 5. Explain if 50 will be part of this pattern. Now this is also a very important pattern. It is called Fibonacci series. You add previous 2 to get the next term. So the pattern is add previous 2. To get next number. So 1 plus 1 is 2, right? So when you add these two, 1 plus 1, then you get 2. And then when you add 2 and 1, you get 3. And when you add 2 and 3, you get 5, and so on. So the next number should be what? 5 plus 8 is 13. Do you see that? Now, to get the next number, you have to add 8 to 13. So it will be 21. And 21 to 13 will be what? 1 plus 3 is 4. And 2 plus 1 is 3. We get 34. Now if I add 21 and 34, I get which number? 5 and 5. I get 55, right? So I do not get 50, but I get 55. So in this case, 50 is not within the pattern, right? So 50 is not there. Is that clear to you? So that is how we figure out the answers for such questions. I hope you find it interesting and useful. Now, amongst input-output pattern rules, these are one of the best questions, and they have been taken from previous test papers. I hope it really helps you to go through their solutions. I'd like you to once again attempt the paper on your own. That should help. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.